Hi there and welcome to today's class. For today, we're trying to find the resultant of a concurrent complanar forces, right? So the question says, find the magnitude and direction of the resultant of the force, perhaps forces, not force, forces, right? So I'm having this concurrent coplanar force. How do you solve this? How do you find the magnitude and direction of this? Let us first, my first task here now is to resolve my angle, right? My forces at an angle, resolve them into vertical and horizontal components by applying the concept of resolution of forces. We said resolution of forces is simply the conversion of forces at an angle, in this case, into vertical and horizontal components, right? So let's find it. Let's resolve these forces here. Now, note something, please. Let me make this thing easy. When it comes to graph, we have just two coordinates. We have the x, y coordinate. Let's say I have a graph as this way. I have just two coordinates: the x coordinate, y coordinate, x and y coordinate. All right. With this little idea here, right? Look up, please. Look up, please. I want to resolve this one here. First is first, this force and this angle. Hang on. What is their what is their coordinate? Their coordinate becomes something of this nature. This is my coordinate here. For this force and angle, the coordinate here is what? This is what if I say that what's the coordinate, I mean the y-axis and x-axis of this one becomes, this is y-axis here, this line here. This one becomes what? The x-axis, which I've drawn out this way. When you are done drawing out the coordinates of that force and angle you are considering, your next task now is to look at that angle. The angle is slipping on, or perhaps lying on this line here. So automatically that becomes cos. So I'll have, consider the force first. This one becomes 300 cos 30 degree, please. Hang on. First task, I'm seeing a force and an angle. What's the first task? Draw out the coordinate. I mean the x-axis and y-axis of that section there. So this is my y-axis and x-axis of that section here. This is here. When you are done with this, the drawing, the next task is consider your angle. This is your angle. Your angle is lying on what? Is it the x-axis or y-axis? Is lying on x-axis, and this is my line of x-axis here. So this line becomes what? Cos. So you consider your force first, then of course the angle you are given. Automatically, the upper one becomes 300 as the force. Next up, this is cos. It becomes what? Sine 30. I have resolved. When you are done resolving this one, move on to this. Let's resolve this. The coordinate of this one, something of this nature, right? True or false? True. The y-axis and x-axis for this one, this is how it look like. So the angle is lying on this one, the x-axis. This is my x coordinate. So this becomes what? This line, this arrow here becomes what? Cos. So I'm having what? 24 cos the angle 26.56. This one becomes 24 sine 26.56. I'm done with this one here. Let's move to resolving this one. If I resolve this one, the coordinates of this one will look like this. It's not that I cram it to. Look at it. This is what I'm seeing here. This is here. It's not that I'm cramming it. What you are seeing, draw out what you are seeing, the coordinate of what you are seeing. This is here. For this one here, this is here. For this one, looks like this. This is here. Now the angle is lying on this one, which is this one here, right? So it becomes cos. So I'll be having 200 cos 60 for this one here. For this one, because of the 200 sine 60. This is where the work is. Just not to do this, you are done. Let's get the coordinate of this. Let's resolve this one here. To resolve this one, it looks like this. Look up. It looks, let me do it here so that I can see it very well. It looks like this. Something of this nature. Observe the coordinate becomes the x and y becomes something of this nature. the angle is lying at what? The x, which is this here, becomes cos. So I'll have the force first. That's 390 cos that's 67.38. This one becomes 390 sine 67.38. When you are done resolving, as in this case here, now we are going to find out what the magnitude and direction of the resultant. So don't forget that we said our magnitude for calculating resultant force is simply what the R. Let's find the resultant force, please. Sorry, the magnitude and the direction of the resultant force here. So don't forget that we said for the magnitude becomes R is equal to the square root of f of summation, the summation of f of x all squared plus the summation of f of y all squared. This is correct. I can choose to say R is equal to the square root of summation of h squared plus summation of v squared. You are still saying the same language. This is the same language, irrespective of whichever we use. The same concept, please. The same language. Summation f of x and summation h are the same thing, please. That's the concept. If this is true, that is first, for me to find my resultant, this R here, it means that I must know two things: summation h and summation v. That's it. So let's calculate for summation h. Calculating for summation h. This means that, okay, calculating for summation h, it means that I'll consider two things. Consider upward force to be positive. H is horizontal. Right force to be positive and left force to be what? Negative. We have discussed all this concept in our last class, right? Check the playlist on structural mechanics. You will see all this concept. We have discussed all this concept last class, so that's why I don't want to stress myself in explaining why all these are this. So calculating for forces, the addition of forces acting along horizontal component. That's the meaning of this one here. So consider that right force is positive, left force is what? Negative. If this is true, summation h will be equal to, now look for all the forces acting in this manner or this manner, lying down, either facing right or left. That's horizontal. Look at this one here. One horizontal, another horizontal, this is horizontal, under horizontal force here. So in this system now, I have 4 horizontal forces, right? So it means, let's start with the first one here. Start with this one. This is facing what? Right, positive side, right? So that becomes 300 cos 30. I'm done with this. Plus, look at this one here, facing the left hand side, that's negative. So I'll change this one to minus. That's 224 cos 26.56. I'm done with this. First one, second one. The third one is this, facing left hand side, that's negative. Negative 200 cos what the 60. Final one, the last one is facing right hand side, that's positive. That becomes plus 390 cos, that's 390 cos what the 67.38. 67.38. Let's get a value for summation h by using our calculator. All right, 300 cos 30 we give, right, 300 cos 30 we give this, minus 24 cos this value here we give me this. This is a minus sign, minus 200 cos 60 we give 100, plus I have a plus sign, everything here we give 150. When you are done with all this, sum them up, or perhaps simplify them, I'll have my summation h to be this value. You can call it summation h, and you can what? Call it summation f of x, as we said here. Some lecturer do use this one why some use this. So just know that they are the same thing, please. All right. I'm through finding for my horizontal component forces. What next? Calculating for what? But a summation of v. I'm done with summation of h. Let's get a summation of v, which is the same thing as what? Summation f of y. So consider something that upward force is what? Positive. Downward force is what? Negative. So it means that I'll come back to this system here. I'll pick out all the forces that are acting what? In this sense. Either up or downward. Observe that this is acting upward, downward, and downward. So I'm considering them here. So let's start the first one here. This one is going upward. That's the positive sign. So I'll have 300 sine what there? 30. This is going upward. That's positive. 24 sine 26. 24 sine 26 point what there? 56. Next up, all right. Sorry, I have a little issue with my camera, so that's why it is really misbehaving. Sorry. My task now is that summation v are all this here, as we said. Consider the vertical, as we did here. So if I punch this one here, 300 sine 30, I'll have that one here. If I punch this one, I'll have that value here, 10.73. Minus this one here will give me this, and finally this one will give me this. So it means the summation v is equal to, if I punch everything here, I'll have this value. So now to get the resultant is not simple. R is equal to the square root of what? Summation h squared. H is what? This one. I have it here, square it. Plus summation v is this value here. I'll square it, as we said here, summation v. Right? So take the square of this. I have the square of this. I have this. Add them up. I'll have this value. Take the square root of this value. I'll have this. So the answer, the R is equal to 470.9 is simply the what? The magnitude. Don't forget, and direction. So direction becomes what? The angle. And we said angle is what? Tan theta is equal to what? Summation v over summation h. If you recall in our last class, summation v is this value as we established. This one here. Ignore the negative sign, please. So over summation h now will be equal to h. That's 288.34. If I divide the two, tan theta will be equal to 372.37 divided by 288.34. That will give around 1.2914. Take tan here becomes theta is equal to tan inverse of 1.2914. So theta there, therefore theta is equal to shift tan. So I have 52.24 degrees as my direction. So this is how to find the resultant of this given concurrent coplanar forces.